have to get closer. Welcome everyone to this Unconference session. It's not really the typical kind of Unconference I've ever been to. It's more like a facilitated panel discussion and debate. We really want to make this as interactive as possible. I don't know if anyone wants to move further forward, but we want to kind of get the opinions of the people that are in the room. So the first thing we want to do is to get you to look at this Slido. So the first question is to try and get an idea of the people that are in the room. Just to run through what we're going to do, we'll have this Slido, and then we have a panel, and I'll introduce them very briefly, and each of them will then give a pitch, and then we'll ask if you have general questions. We'll also take questions from the Slido. And while we're running this session, you're free to submit questions, especially those online who can't raise their hand. Submit those questions directly. So we've got a panel. I don't know if you guys want to take your seats. So we have Paolo. Paolo, who's from ISTE. Yeah, I think, you do the catwalk. I'll give you like a really brief summary. If you want to add anything, feel free. There's microphones. But Paolo's from, I call it ISTE because I can't pronounce the whole name, and he's CTO of OpenAir, which is involved in a lot of EOSC and EU level projects interested in infrastructures. We've got Josephine, who's Open Science and Fair Data Policy Specialist at CSC in Finland. Do we want to do applause as they come up? So she works on a lot of EU projects as well. I work with her in Fair Impact, and she's interested in ways to incentivize fair and open research. Then Michael, who I've not worked with before, he's the dark horse in the room. So he's the chair of data science at Passau, which I learnt today is in Germany, and is coordinating the Horizon Europe open web search project, which you'll hear about. And Annalena, who's not going to give a pitch because she's an invited guest at providing a user perspective invited through Fair Call for EOSC. And she works at DKRZ on climate computing at the Climate Computing Center, but more importantly probably, she's in charge of B2Find, which is EUDAT's discovery portal. Okay, so I think we'll start with the Slido. Oops. Can we go to the Slido? So we're just trying to get an idea of, which kind of community or project you're involved in. Oh, I can see over here, can I? No, I can't. So, okay. I think it's a multi-choice. You can click more than one, right? Yeah. Changing rapidly. Who's going to win? Do we know how many responses we have altogether? Oh, yeah, 30. Okay, 30. Is there many people online? Don't. Okay. Probably. Okay. So let's go to the next. Oops. No, sorry. Next question. Okay. So what we wanted to find out is how people are trying to find data at the moment, whether you're using kind of generic search engines or specialist ones, or there's other ways, or if you're talking to your colleagues and they point you directly to some data, for example. So, science data. Sorry? You mean science data? Any kind of data you use for your work. So if you. 。
Yeah. 。
Yeah. 。
。
So it looks like Google is everyone's best friend, which I think is not a surprise. So for the thematic search, anyone have any examples of what they're using? PDB, okay. So specific repositories searching within, yeah. Hmm? Yeah. Okay, we've got 39. So let's go to the next slide. Okay. This is a word cloud, right? Yeah. So knock yourselves out. Everything that you use. Who's the comedian? But did actually somebody try it? Okay, it's just a joke. Oh. Yeah, we get these afterwards, right? Open air. Paolo's very happy, look.
I'm not taking it.
Yeah. Did Paolo pay anyone? Hugging face. Hugging face? Is it something? Okay. Okay. I'll do that when I get out of here. Don't put anything weird on there because I end up Googling it afterwards. I'll get in trouble.
I like the wife.
You like the what?
The wife.
Okay, give that one more minute and then we'll move on. Google data search. Who uses that? Does it work well? Because it used to not work very well. Okay. Sorry? We'll discuss it later. Okay. Have we got another slide? Two more. Okay. Yeah. So how happy are you with how easy it is to find data on the web at the moment? Because mostly we're talking about web data, right? So Google is broken. If we incorporate the previous answer, everyone's using Google. So Google's broken. Anyone want to elaborate on what takes work? Sorry?
You have to use several resources. You have to go through and test here, look there, including Google. It can help, but
yeah,
it's not perfect. Nothing is perfect.
Yeah. I think the numbers have stabilized. Should we go to... Oh. Sorry, more comment. Okay. Anka.
I just wanted to say that, for example, only for climate science, there are about 200 repositories in the world. So it takes a lot of time to... Of course, nobody goes through all of them, but it takes time,
Yeah.
a lot of time.
And Google doesn't find any of those?
Well, it doesn't find everything.
Yeah. Okay. And this is a good one. What improvements in findability would you like to see implemented? And we've got a lot of kind of providers and a user perspective on the panel here. So just free text.
This last question, so I guess we can take this up.
Good point, yep. Anyone at this point have any questions for the panel or general questions for everyone else that's in the room? Otherwise, we'll start with the 5-minute presentations. It's not too long. that's. Do you want this?
So Jack, can I just click and go back and forward? Right? So, hello, I'm Paolo. I know many of your faces, and I have 5 minutes, so I'll try to go as fast as possible. So, first of all, for many of you it's obvious, but I'd like to highlight the fact that we're going beyond scientific publications with Open Science coming on. So it's not just about publications and scientific publications like article, thesis, book chapters, and so on, but we are exploring other things and other aspects of science. There's the dissemination and communication side, which is very relevant, and today, unfortunately, not very part of the curricula, especially when you are investigated by institutions or in the hiring process. Then we have research data, research software. We have all the relationships between such objects, which are extremely important for both evaluating impact and discovery, so navigation and reuse of the objects, so the connection between publications that describes data sets or software, and potentially also how the software is connected to the data. And on top of that, we have this notion of research objects, which has started many years ago thanks to Manchester friends, some of them here, and has evolved into many different implementations and notions. Our crates, of course, raids more recently, and as you will see later on. So how do we expect to move into this complex space, right? So we'd like to search, of course, keyword search and so on, but we also like to browse and access this graph of knowledge, because in fact it is a graph. So these nodes that are representing publications, data, software, tools, services can be browsed effectively because they're connected by relationships. And we would also like to filter them by many indicators which are now coming forward, not only impact indicators, but usage indicators, for example, or influence or popularity and so on. And of course, we would like also to have automated ways of getting feedback about this data. So we'd like to know, for example, without doing a move, at least originally, or just by acting on a website while you're searching, to be fed with information that I may be interested in. Not overwhelmed, however, not a tsunami of information, but only a selected part of it. And here I'm talking all sorts of users that you can think of in the EOSC perspective. So researchers, but also organizations interested in monitoring, policymakers, interested in trends and investments, and so on. So it's not an obvious thing. I'm not mentioning here many other things like LLMs, chatting basically with the data. I'm focusing, of course, on what we've done in Fair Code for EOSC. Fair Code for EOSC was a very interesting project that was trying to enhance the core of the EOSC core at that time, developed into the EOSC Future, with many services around them. Some of them were about research discovery. We built what we called the Fair Code for EOSC Research Discovery Graph. There was there a nice picture of a graph that disappeared, I don't know why. And it all starts from an original set of information that existed before the EOSC came in, that are feeding what is called the EOSC Knowledge Graph, that today you can access through the EOSC Resource Hub that was presented today. And from the EOSC Knowledge Graph, we built a new graph, the Fair Code for EOSC Research Discovery Graph, that was basically a graph that was enhanced with a number of pieces of information that can facilitate search and discovery. Indicators, communities especially, so slicing the graph into thematic perspectives, and rates. And rates are one of these manifestations of research objects that basically represent a research activity together with all the participants to the research activity, the organizations behind them, and over a given period of time, also the research products that have been produced by this activity. So in this context specifically, we approached these three challenges. So we came up with a graph basically that is has this data model. So you have products in the middle, publication, software, data, etc. Then you have organizations also as part of as affiliations of the authors of the projects, but also as part of the projects that have funded the products. And we attach the indicators to the products themselves. We have a number of indicators, as mentioned before, popularity, influence, citations, many others through which you can filter through. We have the notion of community that allows you to slice and view the graph from this perspective, and we added this notion of raid. Actually, the notion of raid was interesting because there is just one implementation of a rate registry that we have implemented in the project, but there are not so many rates. So we have implemented techniques, methods, AI, basically to explore the graph and build rates, potential candidate rates. So we identified objects like publications, data, and software that are related because of common authors, common period of times, common topics, and we kind of suggested that it could become a rate. So you could search for the package of the objects rather than one object at a time. So you can view the graph as a collection of or as a collection of rates, basically. So when you're searching, you're sent back a package, right? These things match what you're asking for. And it's interesting because you can find experiments as a whole, okay? So basically, this is the last slide. You have a graph, and on top of it, you have portals that allow you to access the graph in various manners. One of the things that we've done, and is interesting, is also to explore natural search mechanism. So we basically allow a user to specify in a natural language, English, not Greek, I'm sorry, not Arabic, a search, like I want to have all publications in this period that are linked to data, something like that, and get back an answer, okay? So the idea was to translate a graph into a database that would be able to support this kind of queries. Then, of course, through the same portal, you can search by community and get recommendations for a community, so get all results that are related with a specific community and browse them, and also experiment with different kinds of indicators and let's say measures of influence or popularity or quantifying somehow the existence of these products based on your intention or reuse intention. And that's it. Thank you very much.
Anyone have one quick question for Paolo? Or we'll move on.
Can I say quickly something about the Slido?
Yeah?
So we still have the last question for the poll open, but you can also use the Q&A as in other sessions. In the Slido, it's behind another tab. So please feel free to add your questions to the Q&A in Slido.
Okay. No question for Paolo. Next is Michael. Here's your clicker.
Yeah. Thank you very much. Hello and welcome from my side. So I'm the dark horse in the room, as I learned today, and I will try to make it a little bit wider, this dark horse. So I want to take the 5 minutes to present to you the openwebsearch.eu project. It's a project not within the EOSC community, so it's outside of the EOSC EOSC sphere, if you want to put it. It's funded by the NGI unit, the Next Generation Internet unit of the European Commission. And I want to try to make a connection to the EOSC community and also in terms about finding, analyzing, and utilizing web data for research. So the motivation for the project is based on the observation that web search, as we have seen in the poll, everybody is using Google on a daily basis, is actually a critical infrastructure that we need to navigate the virtual world, and the virtual space, the web. It's similar like you need GPS for the physical world. However, different in the virtual world is that this critical infrastructure is managed as an oligopoly. We have a few players that dominate the market. They deliver some service, and the service is sometimes quite good and helpful, but still there are some effects like missing digital sovereignty, especially in Europe, reduced user experience, also limited innovation potential for upcoming search engine, new startups. And also, as we've seen in the whole AI field, web data is a driver for innovation and research beyond web search. And that is critical also for getting the ability to handle and manage this data. Yeah. There are some challenges like high infrastructure cost, broad range of technical skill that is required, and also legal uncertainties, which leaves small innovators behind. So the idea of the project is to build an open index of the web, which is what I will explain in a minute, what this open index exactly is, and the corresponding open infrastructure. On the one hand, to restore an open search ecosystem so that there is more competition in the field to build new, maybe more tailored search applications, but also to go beyond and to empower Europe's researchers and innovators to businesses also to systematically tap in the web as a resource, as a valuable resource to do so. We have 4 objectives. That is first to develop an open technology stack, and second, and that is similar to the EOSC notes, to also have a network of infrastructure provider, but in our case these are HPC centers, because we need a lot of compute and a lot of storage, and we want to combine them to have the necessary resources for building an open web index. We also want to build a community around that, showing that there is value for such an open web service, and show that there are added services, hopefully also for research. So who are we? We are 14 partners. You see on the left side the research partners, mainly in the area of information retrieval, natural language processing. We have supercomputing centers, 2 Euro HPC centers, CSE, IT4I, and then also CERN and LAZ here in Germany. And we have a number of NGOs and businesses for driving that endeavor. So what is now this open web index? Well, a web index per se is a data structure for fast query-based access and ranking of web documents. It's the core of every search engine and web search engine like Google, and for sure the one thing that Google will never ever make publicly available. And so our idea is, our proposition is that we are collaboratively creating such a web index in an open and transparent way, which means open technology, but also accessible for everybody. For empowering, as I said, small innovators, and creating an ecosystem not only for web search, but also that goes beyond web analytics, for example, or also AI. And the basic idea is shown here, because the biggest problem is that the web per se is large. We all know that. It's exabytes of data. And you need high-performance computing infrastructure to bring that down to a manageable level, which is then in our case this web index, which is then several petabytes. So for example, the Google Web Index is estimated to have 70 petabytes in size. And something similar is also in our vision, but of course it will take a long time. And then the idea is that this index is openly available so that one can slice and dice it as needed. If you want to collect or finish resources on research on a particular subject matter, it should be a matter of minutes to take that slice from the index over the last 5 years and then put it in any use that you want to have for your special search engine. Or if you want to find author affiliations or something else, as we have discussed, in web pages from publisher, that should be also easily doable by accessing this slice. So that is the vision. I don't go into the technology stacks, just the status where we are. The project is now in its third year, so 2 years have been passed. We have now roughly 10 billion websites in our queue for downloading, so in the crawler queue. We already crawled 2 billion websites from that, which are available as index, roughly 185 languages, and roughly 370 terabytes, and which means we have that continuously running with 1.5 terabytes per day, which is approximately 100 million URLs that we crawl, analyze, pre-process, and index per day. It's not yet perfectly available for use, but we are working on that, and hopefully in November we will provide daily index updates on a daily basis. We also filter for malicious and adult content and try to make it as clean as possible, because the web, you don't want to know what you can find everything in the web if you just scroll. Yeah? So how can it be used in the context of research and search and findability for research? One of our partners, the German Aerospace Center, the DLR, is developing an open geoscience search prototype where they have their special sources internally. Yeah? They have their publication literature from DLR. They have geospatial information with satellite images and Earth observation catalogs and whatsoever is there in a special case of their science field. And what the Open Web Index then provides is additional resources from the web. So what we also do here is we geolocate the web pages so we know which web page talks about what. So for example, if you want to analyze the Ahrtal flooding, then they can pull in some data that relates to Ahrtal and bring that in relation to their own data. And then they build a nice interface on top of that, and that's their own prototypical search engine that they run. And I think there are many more of those kind of use cases that can be done with web data, and I'm happy to discuss about that. And so now I'm hoping that I'm no longer a dark horse, but you know me a little bit, and I'm happy to hear your opinion of the discussion. Thank you very much.
Anyone have a quick question for Michael? Question over here.
Would it be useful to implement in our resources, I mean, information resources, this marketing system of Google, which is using...
You mean microformats, or?
Yeah, well, yeah, exactly.
Because
that could help to...
I think yes. So in our pipeline, we are extracting microformats, and that is indeed helpful in certain cases. For example, in blog articles, where we then get the title of the blog, the author, the date, and the exact content, and we don't need to parse that anymore from the web page. So I think putting microdata out there on the web page and then harvesting or crawling them and integrate them could be very, very helpful. I think that is. We saw that in Google in the stars and in the ranking. We just did not apply it for science, and this would be the
Well, it's not yet used in science, but it could be, because it's very useful.
Yeah.
And using schema.org as a vocabulary.
There is even another standard called now green.txt, where computing resources or cloud providers could potentially link to resources of how much energy and CO2 is produced by the... So I think there is a lot of potential for those kind of standards in general.
Okay, thanks. And Josephine, to finish up the pictures.
Thank you. Hi, hello. So my name is Josephine Nordling. I work in a Fair Impact project as a work package lead addressing persistent identifiers. So this viewpoint is maybe compared to the previous two a little bit different. We also address other topics within the Fair Impact project, but this is just one of those topics addressed there. And also, maybe before I go to the different tasks related to persistent identifiers, just want to mention that this project is a coordination and support activity. So that means that we do not develop any services or tools ourselves, but our mission is to expand FAIR solutions across European communities, and by doing so, we provide recommendations and best practice documentation on various FAIR enabling tools, FAIR enabling services, technical specifications and practices. So here on this slide, you can see all 4 tasks related to persistent identifiers. First, on the left-hand side, you can see a piece of work that is done quite intensely together with PID service providers, where we have formulated a joint value proposition for PID usage. We have also proposed some requirements needed for a coordination mechanism for PID service providers. And what is yet to come is to define a long-term vision for PID usage within EOSC. So there are quite many useful pieces of guidelines coming up still in this project. We run until the end of May next year, so we still have around roughly 7 more months to complete our work. Then in the task 3.3, we work heavily together with data managers in writing tailored EOSC PID policies for end users. So there is also the end user perspective coming in here. And furthermore, in the task on the right-hand side, we engage in a sort of broader sense to provide PID implementation guidelines. But the task highlighted here is the one that I will mostly be reflecting on today. That is a task where we work together with 8 integrated use case partners representing various different scientific disciplines. For example, agriculture and food, life sciences. We also have the software heritage being a domain agnostic one. So there are different, sort of quite many different viewpoints to this task, and what concretely we are addressing and doing in this piece of work is that we are identifying and documenting best practice documentation on PIDs. And as I said, in this task, the end user is the target group of this documentation. So we provide them on different levels of aggregation, for example, for managing workflows, managing datasets, and research objects. And the ultimate goal, hopefully, is to get a more exact data citation and a broader and more targeted use overall of PIDs. We also aim to, for everything that we do in the project, to sort of translate the recommendations made for one scientific domain to another, and try to sort of broaden the audience and the potential readers, and to make use of what we put out from the project. And this way we also broaden the impact of our outputs. So we are very, of course, given the name, we are really interested in of course, generating added value for the entire research community. And we have so far organized quite many different ways of engaging also outside of the project through various different workshops. So here is the use case structure. Firstly, briefly mentioning the one on the left-hand side relating to PIDs in data production workflows, where we automatic workflows documenting data provenance in processes, and PIDs for instruments, PIDs for software. You can see the partners involved in those tasks there as well. Furthermore, we work on PIDs in complex data citation for different types of entities, including versioning, collections, and hierarchies. And lastly, we have a task on PIDs in sensitive data. And there we focus mostly on kernel metadata and related owner rights. And the idea is that all use cases should also to a somewhat extent also focus on the cross-cutting themes you can see on the bottom of the slide here. For example, reproducibility and versioning and granularity. Okay, so over to the collaboration and how we go about doing that. So we collaborate, as I already briefly mentioned, quite a lot with other research communities across Europe, but also beyond. On the left-hand side, you can see an example of, for example, all the FAIR national roadshows that we have organized most recently. There are still a few more in the pipeline. So these are focusing on fair data management. They have a specific topic, and experts within that specific topic are invited to present and discuss, and it's open for everyone, so it's not only for that specific country, but it explains and exemplifies the situation in that specific country. We also have a support program engaging quite a lot of different stakeholder groups. So far we have supported 121 teams consisting of almost 300 participants. So the topics can be of various kinds, but the one related to PIDs most recently was on guidelines on creating EOSC-compliant PID policies. So the data managers were the target group of that support action. Furthermore, we work together with different projects. So we have collaboration plans with, for example, FAIR-E, Skills for EOSC. FAIRCore for EOSC is a project we work very much with. We also have collaboration plan with Horizon Zen, developing the Zenodo functionalities some more. We also engage in EOSC more broadly, for example, in the Horizon Europe collaboration network, so to say. There is this one on technology, another one on dissemination and engagement. So there are quite many different ways of sort of engaging in the EOSC agenda, providing, for example, joint feedbacks on different reports and on the MAR, on the roadmap, and on the SRIA, etc. So there are quite many different ways we are contributing to collaborating with others. And one I forgot to mention almost is the one that you can see on the right-hand side, the Synchronization Force workshops that we have organized once a year, each year of the duration of the project, which is sort of a coordination mechanism bringing together similar-minded projects and initiatives across EOSC to discuss and align and plan ahead topics of mutual interest. So many more examples I can mention, but I think maybe in the discussion then we can have some more practical examples. So that was all for me. Thank you. Sorry.
Great. Thanks very much. Anyone have any initial questions? Question, Wim?
More of a comment now that we also have persistent identifiers in view. There's anything between maybe 500 million and about 2 billion persistent identifiers of interest to science, depending on how you count them. So it seems to me that using that list as a sort of a priority for the open web search algorithm to process makes sense, because it sort of it has a high probability that it will be useful for scientists. So I don't know if the open web indexing is focused entirely on making it more useful to scientists, or whether it's for the EU citizen in general. But certainly that's a perspective maybe to make the prioritization focused on what's of interest to research.
There's another mic by you, Paolo.
No, now it's working. Yeah, okay. Yes, well, the Open Web Search per se is an initiative that tries to cover the whole spectrum of search. So it's broader. It's a way to try to gain a bit of digital sovereignty in the field of web search, and also tapping the web as a resource, as I mentioned. And the project is small compared to the amounts of money that is available to Google and co. But you're right. I think one particular aspect is that if you have the web data available, to cut out those slices that are of relevance and of high relevance. And I think that is one goal we have, and I would hope that there is a science search case where web data could be used to augment different scenarios, and persistent identifier play for sure an important role there, as I pointed out in the case.
On this matter, we are discussing with Open Web Search exactly on that. So if it's possible to, it is, in fact. It is possible. Actually, there's one thing he didn't say, but it's actually relevant, and it's the fact that their pipelines can somehow be customized. So you can actually add a little piece of code at the end of the pipeline that helps you extracting exactly what you want, right, and have it fully ready for a use, which is very interesting. So we're exploring exactly your suggestion, not only with persistent identifiers, but anything that is an identifier within the record or information that is of interest.
Maybe if I can quickly add, Google has also done something similar in their search services, because they have outsourced the extraction of important data from web pages to whom? To the webmasters. There is a console out there so that you are adapting it, that it fits the index. So I think we have to do something similar.
No, and then just if you are building this link, please retain the information, because then we have a reverse PID lookup too, to say, give me all the PIDs associated with this URL.
Anyone have any more questions in the room? Is there anything online? Any questions online?
So from Slido, as a manager of a dataset repository, what are the key technical steps to ensure optimal findability of the data?
Nobody wants to say it. Okay. Well, of course, you have to make your metadata available as much as possible through all possible channels, all possible standards. But then it's really up to you also to pick which are the channels you want your research data to be available and searchable and findable. For example, as OpenAir, we offer solutions if you want to offer visibility to the EOSC node and to the Commission for reporting through the EOSC participant portal. Or if you want to do certain kind of analysis and monitoring, the open web search instead has a completely different perspective. So you're going through a channel that is much more generic. So your results will be part probably of queries and result of queries together with other potential websites that are not necessarily to do with science in general. But it's interesting anyway, because you may make your content available through those channels. There are many other ways, and that could be interesting for you to explore. So Google itself, it's actually a way to do it, and you know how to, right? So it's, if you want to be schema.org compliant or similar techniques. So it's really up to the repository managers to decide which is let's say the formula and the club he wants to join. B2Find, for example, is another example here. So I can mention many others. So it's really up to the investments, because of course it takes an effort to become compliant and interoperable with others, and it takes time to maintain such compliance level up to a certain extent, because standards vary, the policy varies, acquisition policies varies, and you have to be up to it. So it's a clear investment for the future, unless you're super rich and you can afford a team of 40 people.
Yeah, so I mostly engage with this topic from a policy point of view, but if I were to comment on a technical implementation that wasn't already mentioned by my colleague here, so I would say like aggregation. So that would be more on the end user side, so encouraging to put a PID to all the related digital or otherwise objects for ingestion in, for example, a PID graph or a scientific knowledge graph. This way, I think, yeah, this way is a good way of enabling findability.
Okay. Yeah, I'm in a very similar position like Paolo here with the search portals, the discovery portals. One thing I could add is maybe when you build up your repository, you could already check your software. Most of them already offer very good customized solutions to exposing your metadata in various formats, and that can already help from the start.
Last but not least, I needed to think a bit. That's why I'm happy that you go first, Paolo. And I would like to take a completely different answer. I was think about the user interface. So how will your users then search? And I think what we now also can observe is that with the new AI technology that is out there, with retrieval augmented generation as a new kind of way for interacting with the data, you have already a quite nice user interface that summarizes you a lot of data. But the point is the data need to be clean, the data need to be accurate, and I think you need to have very specific data for your use case in there in order that these LLMs and AIs are not hallucinating. And I think that would bring every thematic search for different discipline on a quite new level, because the LLM can integrate all the structural metadata that could integrate potentially also research data and other web resources, if you keep the focus on high quality data. And I think that is quite a nice opportunity. And if I would have a data center with a particular target group for users, I would focus on that application, take the data that we heard that is clean, and go there.
Let me elaborate more. That's a very interesting topic for discovery in general, because the problem we face with data is that either data is very discipline specific, so you are a researcher who knows what is looking for. So I'm looking for atmospheric data. I can use parameters in that. I can use specific facets of my search that are very specific to my science, or I move to a higher level. That is where multidisciplinary science plays and so on. And the problem we have with research data in general is that research data is not really self-descriptive, so it's not textual data that describes, like a paper can describe a scenario and so on. So how to implement a search that is meaningful, especially when you go one level up, and allows you to search through different domains, scientific domains, is extremely complicated. So the point is to gather enough information to make sure that your metadata is rich enough to serve your queries. And this is a generic problem that we all have. So in open science, so it's a completely different perspective. We are used to search for papers. So full text, you know, is the perfect place where you can find anything that matches. Even LLMs, where they work fine. But if you're putting a table in Zenodo, for example, you're uploading a table that contains data, and you specify minimal information in the metadata, the chances that people can find your data because it's useful for them are very low, right? So, and then you need something to be built on top. And this is where it gets exciting from the computer science perspective, of course, for the geeks, not for all of you, but because then is where LLMs can really become handy. For example, if you have relationships with data and publications that are actually describing such science, so you can somehow propagate that context, provide a semantic or meaning to the link that you have between the two, and make something that looks like a search work for your data. For example, can you please tell me which are the best data sets used in this context, cited by at least 3 people, and that were performed in between this range of years, right? This kind of queries requires, of course, several connections to be in place and reasoning on top, information. This is where it becomes exciting, okay?
Can I just...
Because then people start.
Sorry, Wim, do you want to say anything about the information you're adding on top of Zenodo or through the RDA Tiger work? Because I think that's quite interesting and it's...
So you just mentioned an interesting search. Who is supporting this right now?
Nobody, but I think it's these are matters of research in the next period, because we have information, we have content that can be used, quality of which is to be really understood and investigated, but we have the tools to do that. So we are experimenting already. So it's not production ready, but we have things that work. For example, the RAID that we developed in this project with Tommy and this group are doing exactly that. So we're exploring a scenario with links, and we're bringing things together in the hope they make sense together. So when you search, you find something that is meaningful to the user as a whole, right? A package of information. This is just one of the many use cases you can think of.
So I just want to let Wim talk about some work with RDA, which was related to the Zenodo point. Yeah. Is there a mic nearby?
Yeah, just briefly, in the RDA Tiger project, we were faced with a situation where many of the RDA outputs and supplementary materials are published in Zenodo, but with absolutely minimum metadata, as Paulo explained. And of course, not all of their outputs traditionally have gone into Zenodo. In earlier days, they were published in journals or on institutional websites and so on. So we've supplemented the RDA corpus, as it were, with a graph on top of the catalog that contains, amongst other things, Zenodo. So that already improves the searchability. That graph can be annotated by individuals in the working groups and interest groups and elsewhere to improve the findability of those resources with additional controlled vocabulary or free text annotations. And then, not in the RDA Tiger project, there we'll start, but hopefully able to finish it in follow-up projects starting next year. We are now looking at how to further enhance those searches with AI-supported enhancements. So the simple enhancement that we're looking at is just a vector, not a vector match, but effectively a persistent identifier match. So I can search in open air corpus for a certain number of, let's say, and return the persistent identifiers for creators or authors. And then if it intersects with a corpus that RDA has published, we can at least offer that kind of integration. And then next year, we'll hopefully start looking for vector and natural language processing matches between the two.
Great, thanks. We got one question online, and there's somebody had their hand up over here. Yeah, let's go over here first and then online. Can we put up the Slido results?
I have a quick follow-up question on the example you mentioned of the search. So you mentioned, I think, the 3 best data sets that blah, blah, blah. How do you even define best? I understand, give me all of the data sets that blah, 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 but how do you even define best?
I have an answer, but maybe because I've spoken enough.
No,
I'll give you the most diplomatic answer ever. No, I think the idea is that if you have an object, persistent identified, let's say, you have to be free to attach to the object any sort of indicator. So depending on the use case, what is quantitative, what is qualitative, really depends on what you need, okay? So, for example, I'm mentioning the open graph because it's our baby, but there we're not, in principle, deciding what is the best indicator. We know that we can attach an indicator. We have a standard way to describe the indicators. And then, if you want, as a community, you can inject them into the graph and use them all together. For example, we have the citations, which are a common thing, you know. Then we have the usage counts stuff, so make data count, so downloads and views. Then we have this influence, popularity, which have been derived by many connections, way of citations. So the potential influence of a publication that is published today, right? So you don't have citations, but you can envision something to happen. And there are many others that I'm not mentioning. For example, regarding open science, fairness degrees, fairness indicators, which somehow translate into how good you were in publishing, right? Not in terms of openness only, right, but also in terms of accuracy of the data that you're specifying. So there are many perspectives that you can measure about your science, and you may be interested in all those. So to determine the level of, or the degree of, let's say, trust that you have on the data that you're looking for.
May I add something which I think is related to both?
Very quickly.
Very quickly. I think what is often overlooked is another essential ingredient every search engine that is good does. It tracks usage data. It estimates who has searched for what and has found it in which way. I know that's a problem with privacy and search queries, but I think that is often something that is really also missing in a lot of search portals.
Great, thanks. Can we take that question from online?
Yeah, there are actually several questions on identifiers, so maybe I can pull them together. So first, PIDs are essential, but how to confirm relevance of the search result. Then another question about PIDs, what are the best practices in using PIDs beside the recommendation to use one? And then specifically about the RAID, are there any examples of a scenario in which RAID may be a game changer? So should we go through the whole panel?
Yeah, I'll start with the last one. We have actually quite nice examples within FAIR for EOSC. FAIR for EOSC was designed with the communities that should use these services in mind, and they are represented by 5 case studies. Within FAIR for EOSC, we develop some technical services for EOSC, and these case studies from mathematics, from social sciences and humanities, national repositories, the climate community, and research data management infrastructures. They all picked some use cases and they are testing these components already while they are being developed. They give feedback to the developers, and we had the question was for the research, for one of the services, the research activity identifier, that is an identifier that ties together, for example, a whole research project, all stakeholders, all authors, all data sets connected to it, all the funders, all neatly in one place. And I'm working at the German Climate Computing Center. We are representing the climate case study as well. And in our case, we have reports, the big reports like the IPCC report that tells you how much carbon you can still consume before the world ends, basically. These are huge reports. The calculations take years up until publication, and at that point, the research has to be retraceable. That is for other researchers to check the research. The rates make this possible in a very, very compact, very easy way compared to today's. Well, you've got one bit here and then one bit there, and then the publisher needs to look up people and places. And with the rates, you have this nicely. You have one identifier that gets attached as a metadata element, and yeah, you can, in a machine actionable way, retrace a whole project, a whole experiment, and you have it in one place. And yeah, that would be one example from our Fair Coffee EOSC project for the rates.
That's great. Can we pick up another question? Pick a different one.
Yes, so I would like to reflect on the best practice recommendations on PIDs. So that's a really good question. So, for example, trying to define what is the correct level of granularity. So if you mint a PID for a certain entity, is that the sort of correct level to mint a PID for, so that also the sort of the whole package remains sort of understandable and sensible in a way. So managing, for example, different versions. So we are discussing what constitutes a complex data citation, for example. But also, if you work together with, if you have managed, for example, sensitive data of different kinds. So there is also the discussion on what constitutes kernel metadata, what needs to be inside of that type of metadata. Is it more than going beyond access rights, for example? So these kinds of quite concrete examples, and we try to couple all of the best practice documentation with evidence wherever possible. But sometimes we might also put out recommendations that are not best practices, that might be also bottlenecks, so things to avoid. So do not do this if you're in a situation like this. So these kinds of user stories coupled with some type of evidence behind them.
No, I don't have to say. No, I have a question for you, no, and then I'll ask it. No, on the rates, to add what was said before, I think what is exciting is not just the fact that you have a package of objects that are useful together, but it's also that you are able to search for such a package. So today, when you search, you get basically a list of results that are really individual nodes, individual dots in that graph that we are describing, right? So a list of publications, a list of data sets. And of course, by opening one of them, you can navigate to the objects that are related with it. But it's a different way and different process in discovering how these objects are connected. It's a different thing instead. Imagine if you could search and get back maybe an AI-generated object, because the description, the metadata, the title, the authors, everything, of course, have not been defined by anybody in this case, in the case of the race that we are inferring. that somehow it's representative of this package of objects. So when you open it up, you find all the objects all together. And it makes sense for you because the machinery has managed to put them together in a sensible way. So you will find the 3 papers describing the history of this piece of software that has been developed by this team, together with all the authors and together with the software you're pointing to. So you're opening up basically a subgraph of objects that makes sense for you altogether. It's a completely different perspective. So it's something that has not been done today. So it's a first step towards this kind of experiment. I think it's really exciting. Question for you. You mentioned that you have, because I'm really interested, yes, granularity. For example, recommendations on granularity. This is extremely interesting because when we are collecting information from different repositories, different sources of all kinds in OpenAIRE, we find all sorts of different usages of the concept of granularity. Absurd scenarios, right? So completely. And what is a recommendation that you think is general purpose enough to be adopted across different disciplines, because this is then the major issue, right? So it's...
I was hoping you were not going to ask this, because this is something that we are still yet to define in the project. So we have a final deliverable towards the end of the project, and we are still discussing what would be the correct... There is probably no correct level of granularity at any given time, but it depends on the situation and the data and the discipline at hand. So I'm afraid I don't have a concrete answer at this point, but maybe towards the end of the project, check up our deliverable.
Okay, we're kind of out of time. I think we need to start wrapping up. We have a list here of a wish list for you guys to have a look at. Unfortunately, we don't have time to go through it. I want to say thank you to Heidi and Anu for the help, and the technical team at the back, and for the panel, and for your participation. Thank you very much.